This is IDPs After School, a 2017 proto platform story. My name is Johnny Dallas. I'm the CEO and co-founder of Zeet. I like to say that I've been doing platform engineering for the last 7 years since 2016. Now, I run a company making IDPs easy and accessible for everybody. Today, I'm going to tell you the story of how I stumbled onto platform engineering. At the time, platform engineering wasn't really a term, and so we didn't quite call it that, but some of the underpinning ideas and problems that companies face every day that we now call platform engineering were very real to us at the time. So to start this story, let's set the stage. I mentioned earlier I was on a startup. This was a small team. This was a team of less than 15 people total. We'll go into the distribution of how that worked out later. And while this team was small, we had a really big ambition. We like to say that we were going to be a billion-dollar company or bust. And we were building Little League esports. We wanted to be the esports solution for high schoolers around the world to come and stream their video to our platform, and we would help them compete against each other. Now, to build this product, we had a very complex live video infrastructure stack. And we'll dig into some of those requirements in a moment here. But this was one of the key drivers for why we ended up needing to get into kind of the ideas of platform engineering so early. The infrastructure requirements for the product that we were building were really focused around video. I mentioned that we were building for gamers, and we had this very large ambition. So that meant that we had to be everywhere that they were. Gamers are global. They are on every continent. They are all around the world. And so that meant that so did we. We had to be in every single pop that we could be in. We had to ingest video everywhere. Not only did we have to ingest video everywhere, we had to process this video very quickly. We would have an algorithm on the back end that was detecting events in the game. We had to be able to do this low latency video ingest at less than 15 milliseconds of total latency. Gamers, if you are one or if you know one, tend to play for very long periods of time. So not only were we ingesting video everywhere and having to ingest it at low latency, we would have to process long streams. And so making sure that there was always enough capacity for these streams was really critical. To quantify this a little bit, we would see users stream live video to us for 8+ hours at a time. And this video was not light. Not only did it have to be fast, and not only did it have to be stable, it had to be robust. We had an average of 7 kbps of this 1080p 60 fps stream that was coming into our system. Now, I mentioned that we had a small team. I want to break this down a little bit more because I think it sheds some really great light on why we ended up having to go and build a platform. The team was comprised of about 15 people, 10 of which were what we call application developers. This could be front end, this could be back end, this could be full stack. 2 people dedicated purely to infrastructure, 2 sysadmins, and 3 who were more focused on growth and product and not engineers in this capacity. Now, the real crux of the problem for us and the straw that broke the camel's back for our company was right when we started to take off, right when our infrastructure was really growing, we had our team shrink. Both of our sysadmins, within about a month of each other, retired and moved on. And this came at a really critical time for us in our company's story. Not only were we starting to hit some of the scale, we had to go far further than that. We had a mandate from our CTO to go from 1 AWS region to every single region in the year, 15 AWS regions that were available at the time. So we had a problem. Infrastructure is holding back our company, and we only have software engineers. What are we going to do? The solution that we didn't have the words for at the time was simple. Let's build a platform. Let's approach this problem with software engineering mentality. Let's deal with it like we do any other service, like any other product. So we started to plan this service. What does it mean? What do we need to have in place? What do we need to figure out before we can go and solve this problem for ourselves? The first thing that we did was lay out what the most important pieces were. We landed with 2 tenets, developer self-service and 100% automation. What we meant by developer self-service was because we had this team of 10 engineers who weren't all very infrastructure competent or really infrastructure capable or really infrastructure experts, we still needed them to be able to pull their weight. We needed developers to be able to deploy services, spin up new services, configure some of these higher level infrastructure pieces without having to go and talk to another human. And the 100% automation was really critical here. I mentioned earlier, I was in high school at the time of doing this, and I was the only software engineer that we could dedicate to solving this problem. I don't know if you have ever worked with a high schooler before, but they are not very reliable. I'm happy to attest to that. I can't tell you the number of times that I got paged in the middle of a final, and we really knew that we needed automation and systems more than people to solve this problem. So once we'd laid out some of the high-level tenets and we knew where we had to go spend our time, first thing that we set us out to do was let's standardize our infrastructure. And this was a pen and paper exercise. Let's figure out what are the repeatable blocks of infrastructure that can be used to define one region, and then let's figure out how we can scale that to 15 regions. We also knew that we wouldn't be able to do it all at once. The idea in DevOps, but also in people, of changing everything on a dime is very difficult. And so we knew we had to figure out a rollout strategy. Lastly, this was 2017, and with a more product-focused than infrastructure-focused team, Kubernetes wasn't really on our radar. We'd heard about it, we knew that it was a thing, but we didn't have any maturity with it, and we weren't in a place that we could actually go and adopt it. So let's talk about how we standardized. The first step for us was to find a common standard runtime that we could build our product off of, or build our platform off of. Docker and containers were the clear solution for us, coming from a previous supervisor world. In addition to putting all our applications and services into Docker containers, we knew that we'd need to standardize the log ingestion and metric ingestion systems around them. If we couldn't see what was going on with our systems, how would this automatic platform be able to handle scaling up, scaling down, removing unhealthy nodes, things of that nature? We also standardize how application developers deal with their infrastructure, and specifically how they defined new services. We came up with a custom JSON schema that allowed these application developers to define build commands, run commands, auto-scaling requirements, things of that nature, so they could have control of their own application and hand off to this system. In terms of the rollout strategy and what we came up with there, we knew that everything would need to be able to be spun up in this platform. If we had done any manual actions, that would not scale when we were operating at the scale of 15 regions. And so we would bring everything up first in one completely automated region. If there was any manual steps that were required in that, we would shut it down and try again. Once we had that region up and running successfully, we would think about migrating DNS over, start sending some traffic to it, look at that, make sure it was healthy, and then and only once we had moved all production load balancers over, would we start turning off the old services. We kept them around for quite a bit of time as a backup, just making sure that if there was any incidents that occurred, we would be able to revert in an easy way. One forcing function that made this really easy for us to think about and really easy for us to execute on, we wanted to have a one-click way to spin up a new region. We had way too much to do and not enough people to do it. And so our CTO wanted a button that he could click that would spin up a new region, provision all the relevant infrastructure into it, automatically join the global control plane, and be fully functional from just that button click. I cannot tell you how many times that I clicked that button myself and got 99% of the way through, and some IAM role was broken, or some little script was broken, or some node failed, and we had to start over again. But this was a really useful way for us to make sure that our automation worked from end to end. Now, we don't have enough time to dig deeply into the platform that we actually built. If you're interested, we have a reInvent talk that I'm happy to share that I did back in 2018 about this system in far more depth. But what I can tell you is we had a Python event loop that hooked into the AWS APIs, namely Route 53 and EC2, that maintained the state, made sure everything was healthy, and managed all the auto scaling. We used Terraform to standardize some of the infrastructure templates. The region, for example, all of the nodes and adjacent infrastructure resources that were created were initially created through a Terraform module, which then registered itself with this Python event loop and spun up additional resources. And we had a global control plane that centralized all the infrastructure operations into one system. This system handled everything from auto scaling to provisioning of new nodes, and even handling the day-to-day CI/CD deploys. With this system, any engineer or team could register one of their new application definition models, and that would spin up a new service in as many regions as they defined. If they had a new Git push, we would take that and we would roll that change out to all containers across all regions, and the whole thing was done without any human intervention. This solution worked very, very well for us. In terms of, that's easy to say, of course, but let's get into some of the numbers. In terms of the impact of this platform and this system that we had built, we were able to go from a world of 20 incidents a week, constant downtime, constantly firefighting, constantly dealing with unhappy customers, to absolutely 0 incidents in the first 6 to 8 months after deploying this service. This was really important for us because these incidents, especially in a live video world, are pretty disastrous. If you drop video for even a few seconds, the streamers, the customers would complain. You would lose footage forever, and you could never really rectify that problem. We also measured our impact here in terms of efficiency. We saw that efficiency come in 2 different ways. One was cost. We went from a world of hundreds of thousands of dollars of monthly spend, an 83% cost reduction, thanks to the efficiency gains of having this platform constantly managing which nodes do we need, where, and how should they be being managed. Additionally, we were able to achieve the goal that we had originally around latency. We had a P95 latency of less than 50 milliseconds for all regions and all customers around the world. Not only were we able to improve the internal per region efficiency and improve the global uptime of the product and the company, we were also able to hit the scale that we needed to. We were able to scale to 15 regions and ingest more than 30 terabytes of live video every day. Now, I want to talk about how this helped the developers because, like I said, there was only one person building this platform, one engineer dedicated to it full time, which was me, and we were able to achieve some of these pretty impressive impact metrics. Not only was my job much easier, and I was able to relax a little bit more at school and not stress as much, but our developer team, who was working 24/7, would be able to create new services and change them at will. This reduced a ton of burden from me as the DevOps team, made it so that devs could go and just spin up services whenever they wanted to and just do their daily job. Now, like I said at the start, I feel like we've kind of been in this platform engineering world for the last 7 years. And so I want to share some of the things that I've seen change in the last 7 years and some of the things that I have seen not change. First off, on what has changed. Platform engineering was not a thing when we started. It was a cool idea that we came up with internally, but we had no playbook. We had no best practices. We had no community. We didn't really know how to do this well. We made some stuff work. We would definitely do some things differently this time if we did it again. But platform engineering as a concept wasn't a movement, and it really is now, which is incredible to see. Secondly, the stack has changed quite a bit. I mentioned earlier Python. We didn't really use Kubernetes or have any interest in that. Now, building platforms, we use Kubernetes all the time. There's tools like Backstage, Crossplane, Prometheus. The whole cloud-native ecosystem has made it so much easier to get into platform engineering and build really powerful systems to enable both devs and DevOps engineers to operate more effectively. Lastly, in terms of the ecosystem, there have been some big changes in what cloud means. By the time that we got to the end of this system that we had built at our previous startup, we were in every AWS region at the time, and the bottleneck for us started to be AWS. We wanted to scale to more regions. We wanted to scale to more customers. We wanted to scale to more POPs, but we were limited by the cloud vendor that we had chosen. This is no fault of AWS. They do a great job of getting new regions spun up every year. But today, as we move into an increasingly multi-cloud world, what platform engineering means has changed there. There's also far more tools and more developers really who are thinking about this problem. It's been awesome to engage with everybody here in the platform engineering community and see how people are building and to solve these sets of problems. Now, as we end out here, there are some things that have not changed. Many of the core tenets that we adopted have stayed true. Treating infrastructure as a product, not a set of configurations. Feeling the pain yourself, putting yourself into the trenches, so you know exactly how to fix it. Find the first thing that you can do and do that first. And pushing power to the end user developers instead of centralizing it to a few people who know infrastructure very well. These core tenets were critical to us, and I think are still critical to the platform engineering community as it evolves into its current stage and beyond. Thank you for listening. I hope that you've enjoyed hearing about this platform. If you want to learn more, we'll be in Slack. Thanks.